Hey guys, this is Mrs. Harbin, and this is Algebra 1. We are moving on to section 5.3. Let's start off with a quick lesson opener. State the quadrant or axis containing each point. Just as a quick reminder, since many of you are just learning these axes and quadrants for the first time, this is our x-axis and this is our y-axis. In quadrant 1, we start in the upper right-hand corner and we move counterclockwise. So this is 1, 2, 3, and 4 using Roman numerals. X here is positive and it's negative if we go left. Y going up is positive and Y going down is negative. So therefore everything in quadrant 1 is positive, positive, and I will let you figure out the rest based on that pattern. So what quadrant is negative 4, 3 in? Hopefully you said quadrant 2. What about 2, 5? 2, negative 5, I'm sorry. That is in quadrant 4. What about 3, 6? Positive, positive must be quadrant 1. Negative 1, negative 4. Negative, negative must be quadrant 3. 8, 0. Two positives again, or, oh wait, there's a 0 there. So we're not in a quadrant. We are on a line. More specifically, we are on the x-axis. This is an x-intercept. And 0, negative 5. Again, another 0, so we are on a line, and more specifically, the y-axis. This is a y-intercept. Take a look at these ordered pairs. Do they form a relation? I know that's not the question on the screen, but I wanted to ask it. Yes, they form a relation because we have a set of ordered pairs. Do they form a function? Well, if we check our domain, or all of our x values, we see that none of them are repeated. Therefore, this is a function. Our life application for our unit is this. The student will seek out healthy relationships with people that promote godly behavior and encourage one another to lead wholesome, pure lives according to God's plan for each of us. Functions are all about relationships, how a dependent variable affects an independent variable. And you, as a person involved in relationships with friends and teachers and other adults and your family, you are being affected by the relationships that you are in. Just like the y value is affected by the x value. We want to make sure that we seek out and choose healthy relationships with people who are going to help us do things that are encouraged in God's Word. Our lesson objective for today is that you, the student, will use a relations graph to determine its domain and range and whether it is a function. Plus, you'll graph some simple relations and functions. So we're really going to look at graphing our relations this time around. Take a look at this graph. This is a graph of a function. T is our independent variable. So you see along the bottom here, T, which I'm guessing stands for time, is independent. Our dependent variable is H, which I would guess stands for height. H is the independent variable. So you can see as T increases, H also starts to increase, and then H starts to decrease. So it's doing two different things in this relation. What is the domain? Remember, the domain is the x values. Well, this is a line. How are we supposed to list all of the possible x values that this line is on? Well, we can go back to those inequalities and use inequalities. We see that the farthest left point is 0 of our line, and the farthest right point on our line is 3. So T must be, or can be, any number that's greater than or equal to 0, but less than or equal to 3. So we can use an inequality to represent the domain. What about the range? How would we represent that? Well, the range is all of our possible y values. Again, we have several different y values here. These are not just points, but this is a line. So an infinite number of points, essentially. So we want to list the farthest lowest point. How about we just say the lowest point? And how high, or the highest point? Again, we're going to use inequalities. And we see that our lowest point is 6 and our highest point is 20. So all of the values that I have for y must be between 6 and 20. So in my range, H is greater than or equal to 6 and less than or equal to 20. So when we're setting the domain and range, or stating the domain and range, it's very much like we're stating the numbers here that are at the boundaries. So for our domain, our left boundary was 0 and our right boundary was 3. And for the range, my bottom boundary was 6, and my top boundary was 20. And my whole function fits within those boundaries. If I were to draw the boundaries and extend them all the way out here, that's not a super straight line, bear with me. So there is my range boundaries, and here are my domain boundaries. Oh, that one is terrible. You can see that our function fits within those boundaries. The vertical line test is another way to tell if a function or if a relation is a function. Previously, we said that no x values could be repeated. Well, what if it's already graphed and we don't see our x values? The vertical line test is a way to determine if a graph is a function. And it tells us that if a vertical line intersects the relation's graph in more than one point, it means there was more than one x repeated, and so the relation is not a function. Just a quick reminder, vertical is up and down. So let's take a look at this particular graph. We don't have the points listed, although if we wanted to, we could find all the coordinates, list them out, and see if any x values have been repeated. But we can also use the vertical line test, which we'll do in just a second. First of all, let's list the domain. The domain is how far left and how far right my x values go when I'm dealing with a line. But when I'm dealing with specific points, like I am in this graph, my domain is just the x values of the specific points. So my domain is plus or minus 1, plus or minus 2, plus or minus 3, and 0. You could also list these out as negative 3, negative 2, 1, 0, 1, 2, 3. My range when I'm dealing with a line is my top and bottom boundaries, but when I'm dealing with specific points, my range is just the y values of the specific points. So my y values are 0, 0.5, 2, and 4.5. This relation is a function for a couple of reasons. One, none of my x values are repeated, so we know that's a function, but also no vertical line intersects the graph at more than one point. If I take a vertical line and I pass it through that graph, I don't want it to touch any of the 2 points at one time. And look at that vertical line that just ran through there. It didn't pass any of the points more than one at a time. Let's take a look at this relation. What is the domain? Again, we're not dealing with a line, we're dealing with specific points, so let's list the x values of those specific points. We have 0, plus or minus 1, plus or minus 2, and plus or minus 3. What about our range? Negative 2, negative 1, 0, 1, 2, 3, 4, 5. Now, are any of our x values repeated? If you look carefully, you'll see that x equals negative 1 in 2 different spots. So we've got a repeated x equals negative 1. This relation is not a function because a vertical line crossing the axis at x negative 1 would contain 2 different spots. Let's run that vertical line test, and you see at that particular point it would cross through both of those red dots. So it would pass through 2 different points, therefore it is not a function. Take a quick look at this. Is this a function? Make a guess and let's see if you're right. Hey, first of all, let's start by stating the domain. This is a line, not points, so we want to say the far left point and the far right point. Well, our far left point is 0, but our far right point, you can see that there are arrows there. It keeps going on and on and on and on. There isn't a far right point. So how we would state that domain is like this. Our domain is that x is greater than or equal to 0. So any number greater than or equal to 0, the x value would be part of that line. Remember that our range is our upper and lower limits. If you look at how high it goes, again, the arrow, and if you look at how low it goes, again, you've got an arrow, so it doesn't seem like there is a range. Just keeps going forever and ever in both directions. When this happens, we say that our range is all real numbers. Every y value can be part of the range. This relation is not a function. Any vertical line crossing the positive x-axis crosses the graph at more than one point. If I were to draw a vertical line here, that's not very vertical, or here, you can see that it would cross the graph there at 2 separate points. That means my x value got repeated and it is not a function. Let's take a look at the definition of equations. An equation can be used to clearly define the rule that determines the values of the range associated with each member of the domain. That wasn't a definition of equations, but we're going to look at how we can use equations to graph some functions. So here's a common type of function rule. And our function rule might look something like this. Okay, this is the actual equation here, y equals x plus 2. And here we've been given 4 different values of x. So 4 possible domains. So we're going to create a chart or a table, whatever you would like to call it. I call it a T-chart because, it looks like a T. But on the left, we've got our x. In the middle, we've got our equation, y equals x plus 2. And what we're going to do is plug in these different x values that we've been given, plug them into the function rule, and what we'll get is a y value to create an ordered pair. So when we plug in 1 plus 2 is 3, and our ordered pair is 1, 3. When we plug in 2 plus 2, again, we're plugging them into this equation here. 2 plus 2 equals 4, so our ordered pair is 2, 4. When we plug in 3 plus 2 is 5, so our ordered pair is 3, 5. And when we plug in 4, our ordered pair is 4, 6. We get a 6, so our ordered pair is 4, 6. We have no domain values that are repeated, no repeated x's, so this is a function. Let's go ahead and take a look at what it looks like graphed. 1, 3, 2, 4, 3, 5, and 4, 6. So that's what it looks like graphed. Because we were given specific x values, we are not going to draw a line. We only want these values to be in our domain. We don't want anything between the dots to be in the domain. We don't want anything after the dots to be in the domain. Just the 4 dots, so we do not draw a line. Now, when looking at this, we can tell that this is a function. No x values are repeated, and it would pass the vertical line test. You can see that no vertical line intersects more than one point at a time. Now, what if no domain had been stated for this function? What if they hadn't told us to use 1, 2, 3, or 4? Then the entire line would satisfy the equation. So we can connect the dots, put an arrow on both ends to make a line to show that the whole line, any point on that line, would work with this equation. If the x values are not given, then then x is equal to all real numbers. X is equal to all real numbers. And if you're asked to plot it, you can just use your own x values. We'll try one like that in a minute. Here's another one. We're told the function rule. We're told that y equals 3, and that x must be greater than or equal to 1, but less than or equal to 5, and x is an integer. So no fractions here. If x is just an integer from 1 to 5, then the graph consists of just 5 x values, 1, 2, 3, 4, 5. In set form, the function would be this: 1, 3, 2, 3, 3, 3, 4, 3, and 5, 3. Because no matter what, according to our function rule, y equals 3. If we were to graph that, it would look like this: a point at 1, 3, 2, 3, 3, 3, 4, 3, and 5, 3. We are not going to draw a line because we were given some specific points to try. If we were going to write that on a table, it would look like this. When x is 1, y is 3. When x is 2, y is 3. When x is 3, y is 3, so forth and so on. Hopefully you notice that when y equals just a number, like y equals 3, what you're forming is actually a horizontal line up here that would intersect at y equals 3. If we continue to draw that line, it would intersect at y equals 3. So you can definitely fill out a chart. You can plug and chug, but you might also just notice this pattern right here and use that pattern. What about this function? Y equals plus or minus root x when x is 1, 4, and 9. We saw this on a previous slide, so I'm going to fly through this really quickly here. We come up with 6 sets of ordered pairs. You can see that our x is repeated, so this is not a function. Okay, we're going to plot this points, and it's not a function because x is repeated, and it would not pass the vertical line test. It would pass through that 4, 2, and 4, -2, and all those other lines. Because functions are relations, they're graphed using the same